Have you ever wondered if it is possible to see the future? Humans throughout time have certainly hoped so. But for most of us, that's something in the realms of mystics and fortune tellers. The idea that there might be some way to actually glimpse it is usually considered the stuff of superstition. But that perspective might be wrong. What if you were already seeing parts of the future, just in fragments? What if time could be viewed with past, present, and future at once? Before you worry, this is an Space World Tour video. I originally intended this video to be the last one in my Unified Theory of Everything series, but as I was preparing the best way to demonstrate how strings could explain the principles of special relativity, I took another closer look, and I realized that there were some mind-bending implications of relativity that contradict our perception of what really exists in the now, which we had to tackle first. As it turns out, you might be seeing parts of the future already. And yes, it's time for me to explain with another diagram. I'm Alex McColgan, and you're watching Space World Tour. And to understand everything, it's time to scrutinize time, space, and relativity. We don't tend to think of relativity in the way I'm about to show you, but it's vital that we improve our intuitive understanding of this topic, or no attempt to explain why special relativity really happens will make sense. Besides, who doesn't like having their mind blown by cosmic weirdness from time to time? When it comes to special relativity, you might have felt like you understood the gist of it. When an object travels at high enough speeds, time slows down for it. At least, it does from the perspective of an outside observer. At rest, for the object itself, time seems to go the same speed, in a principle known as time dilation. And curiously, if you traveled at light speed, from your perspective you'd be ticking along as normal, but everything else would suddenly be slowing down. Not you. It feels the universe shouldn't work this way, with both sides thinking the other is moving slower. But this does appear to be the fundamental rule of our universe. An object rate of travel through time seems to be down to the relative position of your perspective. There is no true rate at which things travel through time. Weird already. But I wonder if you are aware of just how far this principle goes. The implications get pretty mind-bending. Let's talk about a second element of special relativity, length contraction. This is a bit of a weird one. From the point of view of an outside observer at rest, if an object were to travel at a large enough percentage of the speed of light, the observer would start to see the object flatten. A ball would become a giant pancake. This flattening occurs in the direction of the object's travel, and it has been shown to occur both mathematically and experimentally. We fired protons in the Large Hadron Collider, and their collision patterns only make sense if this pancaking is occurring. It's very weird, but it does seem to be real. Multiple experiments seem to confirm length contraction, including the Kennedy-Thorndike experiment and experiments with muon decay, where muon particles falling through our atmosphere don't decay as fast as they should thanks to this effect. It's worth noting, however, that just like with time dilation, length contraction is a matter of perspective. If you were the thing that had been accelerated to near the speed of light, you would not see yourself contract. Instead, just like with time, you would start to see everything else contract in the direction of your acceleration. There's some good maths that talks about why this is, but I won't get into that today, as it's the consequences of length contraction I want to talk about, not so much its causes. After all, we want to get to the part where we start seeing the future. And for that, we are going to need a thought experiment. This thought experiment is known as the barn pole paradox, and it goes like this. What happens if you try to fit a 40 meters pole inside a 20 meters barn? Let's imagine the barn has a door on each side, which you can slide the pole through. Now, obviously, normally this task would be difficult to do without bending or breaking the pole. However, if we take advantage of special relativity, it is possible to do this. All you have to do is fire the pole into one open door of the barn at near light speed. Let's pretend for a moment that you can do that. And hey presto, as long as it's going fast enough, length contraction would occur, causing the length of the pole to diminish to our necessary 20 meters. The pole would fit in the barn for a tiny fraction of a second at least before blasting out the other end. Mission success. It would even be possible if you could do it fast enough for you to close and then open both doors of the barn at once while the pole was still inside, proving once and for all that the pole was inside the barn completely for that nanosecond. But what happens from the pole's perspective? Remember what I said earlier. Objects traveling at speed do not see length contraction occurring to them, but rather everything else existing in the universe contracts in the direction of the object's travel. So, we hit a problem here. The pole would still see itself as a 40 meters pole, never a 20 meters one. Even worse, now length contraction is happening to the barn, so the barn is even less than its original 20 meters length, now just 10 meters from the perspective of the pole. So how does a 40 meters pole fit inside a 10 meters barn with both doors closed? It sounds impossible. Surely this would result in broken poles or barn doors. But this is not what the barn sees. So how can two different observers looking at the same event see two completely different things happen? Have we entered a state of quantum superposition, where the pole is both in and not in the barn? Are we about to split apart the universe into differing multiverses? Is special relativity wrong? No, our perception of reality is wrong. There is an answer to this, but you're not going to like it. Watch closely. According to relativity, this is what would happen from the pole's point of view. The pole enters the barn just like we would expect, and then, there. Did you see it? Perhaps. But what did you just see? You just saw an example of the myth of simultaneity. And remember, this is really what happens according to special relativity. Events that are simultaneous from one point of view are not simultaneous from another. To be clear, this is not just a weird consequence of light taking its time to reach us. If we were just dealing with an optical illusion caused by light taking its time to move to our eyes, then we'd see the closer event happen first, and the more distant event happen second. But this is happening the opposite way around in this case, and from the point of view of the pole, the more distant event spatially happens first, and the closer event happens second. In other words, this is not just a trick of the light, but the suggestion that something more fundamental is going on. What is going on? When I first learned this, it boggled my mind. It seemed wrong as a matter of principle. But the more I thought about it, the more it started to make sense, based on my understanding of the universe. And the more startling implications started to arise. Don't worry, I've not forgotten about that seeing the future thing. I'll get to it. Let's take another look at what's happening here, but this time let's bring in a little color coding and our old friend, a 4D space-time diagram. Hopefully you are familiar with these already, as I've done a few videos that have included them. If not, here's a great video we did on the subject, which you should give a look. To recap though, just imagine that all of space has been flattened down to the one line along the bottom of our graph, while an object's motion in time is tracked along the side of the graph. Here is the barn's timeline, according to its motion in space and time. From the point of view of the barn, it is not moving in space, so we draw the arrow directly up. It is only moving into the future. I've painted the shutting and opening of the two doors as two different colors here on the graph. Note that they are separated by space, but they occur at the same moment in time, at least from the barn's perspective. Now, for our first complete perspective of this event, let's add the path of our pole. As our pole starts moving, length contraction occurs, and the pole drops down to 20 meters. Eventually it arrives at the barn, and our two events occur. Both barn doors shut at the same time, and the pole is snugly inside. All good so far, from the barn's point of view. But what does the pole see? Let's make our pole the stationary object in this diagram. After all, This is relativity. And from the pole's perspective, it is the barn that is moving quickly towards it, not the other way around. This makes it easier to assign length contraction to the barn, which is what relativity says we should be getting. We cannot simply add the barn to this diagram as an object that's parallel in orientation to the pole. It just wouldn't work. The barn, now narrower, would intersect with the pole with both doors closing and opening at the same time, so the pole wouldn't fit. But what if we pivot our barn slightly? From this to this? Essentially, this isn't too unreasonable as we've just turned the first diagram slightly on its side. Now, the sequence works. With this, the part of the barn furthest from the pole meets it first, and the pole sees the orange door shut and open. Then, as time goes on and the pole and the barn proceed further into the future, the pole's other end reaches the blue door, which also shuts, then opens. Thanks to this vector in time and space, it's possible for the barn to not hit either end of the pole with its shutting doors. The order of events is right. From the pole's point of view, the barn's further orange back door shuts and opens before the barn's blue front door does. This is what special relativity tells us should occur. But do you see why this configuration is so strange? It implies to me that the barn itself is not simultaneous while it is in motion. Here's where we're jumping from the paradox into my own thoughts about it. What do I mean by simultaneous? I mean that we expect the barn to exist as a discrete entity at a single point in time. It does exist, with every part of it happening in the same now, even if it's undergoing a little time dilation here and there. But the barn the pole sees is not happening in a single now. Part of it is ahead in time, and part of it is lagging behind. And you can see both parts at once. The barn is not simultaneous because you can see it across a range of times. Its length might be contracting, but the dimensional space you see it occupy in time seems to you to be growing. We do not think like this. But the idea has a beautiful sensibleness to it in a universe of 4D space. Like when a racing car swerving to the left causes its right wheel to protrude further forward. When you move to the left on our space-time diagram, it causes the part of you furthest away from the direction of motion to protrude into the future more than the part that's closer. That's just geometry. For the record, this seems to happen as a gradient along the whole of the object in motion. This way of thinking also allows length contraction to conceptually make a lot more sense. After all, if our pole is in motion and the front of the pole is further in the past and the back of the pole is further in the future, then it makes sense to consider where each part of the pole exists in space during those moments in time. The front of the pole that exists further back in time has not traveled as far as the rest of the pole. So, the start of the pole is further back. Similarly, the back of the pole which exists further forward in time has by then moved further through space compared to the rest of the pole. So, the back of the pole is further forward. What happens when you combine a dawdling front with a further ahead, back? Length contraction. The only surprise is that it seems that we can see this in experiments in the LHC and other places. Somehow, we are seeing across a cross-section of time. So, it works. It just feels like it shouldn't. You might think this is a little out there. But consider, what would an object that didn't exist all in the same moment in time look like to you? Could you tell it apart from any other object? Well, it would probably look mostly the same, right up until some part of it changed what it was doing, and you watched as the rest of it caught up, which is what we see here. So it's not unreasonable to think of it this way, and it certainly helps our intuition. This is the state of affairs for objects that are moving. Or, if we are moving, that's the way we see everything else, which has some pretty mind-bending implications about what we are seeing right now across the universe. Of course, this only applies when things are moving at a substantial portion of the speed of light. So in the day-to-day, you probably wouldn't notice it. And because of the great speeds involved, it's difficult to Imagine a scenario where you could take advantage of this principle, even if you could use the first barn door closing to predict the future of the second. There are limits on how fast information can travel after all, and this time stretching is only noticeable when objects are traveling near to that limit. And while I've talked about the future of the barn and the past of the barn, perhaps that's the wrong point of view. To you, these events are all in the now. Your now. It's just the barn that might see things differently, with its own now where it's closing and opening its doors simultaneously. And you are the one who's splayed out as a range across time. But it just causes me to think about the universe in a very different light. Space and time really are just a matter of perspective, because there is no one true now. There's just your own personal path, and the paths other objects take in 4D space. And just because I see time as being one thing in my reference frame doesn't mean it works that way for you and yours. In yours, time might just be more space. So, when I finally release part 4 of my unified theory of everything, that is the strange universe that I will be trying to explain. One where time and space really are relative points of view. Wish me luck. Time and space might be all relative depending on your point of view, but there are some things in life you certainly hope aren't so subjective. For instance, if you go online and purchase a new laptop or snazzy jacket, the last thing you want to hear is the website say, "Sorry, we never received your money," when from your point of view you definitely finalized the transaction. Sadly, this is what some scammers do, mimicking real retailers. They get you to input your card details so they can collect your money, then vanish into thin air, all without you getting that new 40 meters pole for your 20 meters barn. NordVPN, the sponsor of today's video, can help you see such scams coming. NordVPN's Threat Protection Pro can spot a lot of suspicious links or websites, warning you in advance whenever it senses you're about to get scammed, helping you avoid these kinds of threats. NordVPN also protects your privacy while you're online, stopping big companies and other third parties from tracking your data and your connection traffic, which more and more people are starting to care about if the news is anything to go by. And of course, it can change what location in the world you appear to be signing in from, allowing you access to region-specific sites and content. Thanks for watching. Once again, a huge thank you from myself and the whole Space World Tour team. Meanwhile, click the link to this playlist for more Space World Tour content. I'll see you next time.